Hey, Waleed, I don't think we're hearing you.
Oh,
Sorry.
sorry about
Oh,
that.
there we go. There we go.
I was on double mute. Thank you so much for
No
that.
worries.
All right. So again, good morning, everyone. I hope everyone's feeling well and ready for today's session on the Certified Cloud Practitioner test. We're so glad that all of you could join us today. My name is Walid Al Khatib. I'm a technical trainer at AWS. I've been here for about over 2 years now. So other than myself, we also have Dusty, Warren, and Zachary who are going to be answering your questions in the Q&A panel. So feel free to utilize that pane to ask any of your questions throughout the next couple of hours. And they're also going to be dropping useful links in the chat as well. So this session is supposed to run up until 11:30 today. So that's 11:30 Central. But we might finish a bit earlier, so we'll see where we're at. We also will take one break. We'll take a 10-minute break at the top of the hour, um, just to make sure that everyone has time to rest a little bit, so we don't go on for 2 hours straight. Um, a couple of things to note: this session is not going to be recorded. So if it might say that this session is being recorded, but that's only for internal purposes. So we're not going to be distributing any of the recordings after today. We also are not distributing the slide deck, right? We're just going to be going through this deck and answering your questions. All right, so let's get started. So learning goals for today, this course is supposed to sort of assess your readiness for the exam. So if you were, previously studying or previously preparing for this test, it should solidify what you've already done and sort of help you structure your studies. All right. Now, the cloud practitioner exam is divided into 4 different domains. So domain 1 is on cloud concepts. That's mainly going to assess your ability to, articulate the value proposition of the cloud, things around that. Domain 2 is on security around the AWS shared responsibility model, but other things related to how we can achieve compliance and what are the different security tools that we can take advantage of in the cloud. Domain 3 is all about AWS technology. So we'll talk about the different core services that you should be aware about. And then domain 4 is on billing and pricing. So notably for the cloud practitioner exam, they do have questions around the different billing structures and support models that we have in the cloud. They're not going to ask you particularly on, how much a service costs, but different pricing models when we talk about services like Amazon EC2, the Elastic Compute Cloud. What are the different pricing models? And really the best place to go to validate whether you sort of have all the um, technical background needed to register for this test would be the exam guide, right? So let me see if we can, yeah, let me drop this link in the chat actually. So this would be the certified cloud practitioner page. And if you scroll down, it will take you to the exam guide, right? And you also can download sample questions as well, right? So opening up the exam guide, and I'll also drop this one in the chat. So within the exam guide, you should basically treat this as sort of like a checklist to make sure that you are covered for all the areas that would potentially be asked about on this test, right? At the beginning, there's an introduction telling you, this exam would validate your ability to complete the following tasks, the target audience, right? What's considered out of scope, so they're not going to ask you to code or uh, do any sort of things related to implementations or migrations, right? That would be considered out of scope. The exam is both multiple choice and multiple response. So you will see both types of questions on the test, right? Multiple choice would mean that there's maybe 4 options, and then you have to select one of the correct options from the 4. And then multiple response would be maybe there's 5 or 6 options and you would have to select 2 or 3, right? So there's both on this test. Um, Now to pass the test, you need a scaled score of 700 out of 1,000. So 700 or higher out of 1,000, and that's a scaled score. So it sort of works like if you've ever taken an SAT test before back in high school. Um, that's because we have questions that are categorized as easy, medium, or difficult, and not all tests are going to have equal distribution of each one, right? So the idea is that if you answer 8 out of 10 questions that were easy, it's not the same as answering 8 out of 10 questions that were hard, right? So they use that scaled score approach to ensure that each test is evaluated equally. Now, there are 15 questions out of the 65, sorry, 15 out of the 65 on the test that are sort of beta questions. Those are going to be unscored. So we're not sure what those 15 questions are, but you just know that 15 out of the 65 questions on the test are unscored questions, okay? And then scrolling down, you will get the certain domains that we spoke about. So the specific domains, domain 1 to 4, as well as their percentages, right? So we can see that the highest chunk of the exam is domain 3, which is technology, 33% of the test, followed by cloud concepts, and then security and compliance, and then lastly, billing and pricing. And then under each of those domains, here's where you can sort of treat that as a checklist, as I was saying, because under each of the domains, we have subdomains, right? So domain 1 covers subdomains 1.1, 1.2, and 1.3, right? And then under each subdomain, you have the particular topics that you should be aware about, right? So domain 1 would cover defining the cloud and its value proposition, as well as identifying aspects of cloud economics and explaining the different cloud architecture design principles, right? So use this as a sort of resource for you to verify your readiness for the test. With that said, let's jump into the first domain, which is on cloud concepts. And let me just also make sure that I'm pulling up the, okay. Pulling up the questions as well. And okay. And throughout the session, let me know if anyone can't hear me. So I think those were concerns that came up previously where my mic was muted. I'm sorry about that, but yeah. Okay, so let's jump into domain number 1. And as we said, there are subdomains for each domain. So we'll talk about those different subdomains when we get to each of them, right? We'll start with benefits of the cloud. We'll then jump into cloud economics. And then lastly, design principles, right? So those are the 3 subdomains for domain 1. Again, we'll start with the benefits of the AWS cloud. And to understand the benefits of the cloud, we really need to define what the AWS cloud is, as well as its value proposition. So really, what value do we get from running workloads or operations in the cloud, right? And to define the cloud, there are a couple of points that we need to be aware about. So things like the different security services and the features, right? So, trying to implement the level of security that you can achieve in AWS would be virtually impossible if we were doing everything on premises. That's one of the value propositions of the cloud, as well as benefits related to high availability. So making sure that our applications can remain available, even though there was some kind of node level failure. We want to still deliver, low latency and high quality experiences and remain available at all times, right? And then for the value proposition, right, we want to talk about, how can we shift from an on-premises infrastructure management, and also how do we optimize resources in the cloud? So making sure that we're using the appropriate resource types and sizes, and also optimizing costs at all points, right? So with that said, we are going to go through a couple of questions throughout the day. We'll walk through questions, but before we go to the first question, we need to understand how do we actually tackle these questions on the test. And there is a particular strategy that we do like to take, right? So the first thing that we do is we read the STEM, right? That's step number one. Read the STEM. The STEM is basically the body of the question. So we definitely need to make sure that we read it. And then from that, we want to be able to extract keywords, because these keywords can allow us to sort of infer what the answer might be before even looking at the options. And that's really the best approach is if you are ready for the test, identifying these keywords will allow you to think about answers before we actually start reading them, right? So the third step would be to actually read the responses. At this point, we can follow the process of elimination and start eliminating options that are definitely incorrect. And then lastly, identifying the key, right? The key is the answer, essentially, among the distractors, right? So we have the distractors, which are the other incorrect options, and then we have the key, which is the correct one, right? So with that said, let's move on to the first question for the day, which says that the ability to horizontally scale Amazon EC2 instances based on demand is an example of which concept in the AWS cloud value proposition, right? So that was step number one. We read the STEM, right? From that, we want to be able to extract keywords which are related to horizontally scaling EC2 instances to meet demand. So if we have an increase in traffic going to our web apps, we want to be able to dynamically acquire compute capacity or dynamically scale in and out to meet that demand. And we're trying to map that to a certain value proposition of the cloud, right? So after we've extracted those keywords, we might be able to think of some options here or some responses, um, and then we'll move on to the actual responses, right? So with the options shown here, what does everyone think the answer is? And you can drop your answers in the questions window. So A, B, C, or D. Okay, we're getting a couple of responses. Very good, right? So I think we're mainly stuck between B and C, right? That's mainly what I'm seeing here, between elasticity and high availability, right? So very good for those that said the answer was, whoops, the answer was B, elasticity, right? So that is the value proposition that we're talking about. Elasticity is the ability to scale in and out, right? Scale our compute resources, not just out when traffic goes up, but also back in when traffic goes down, so that we can, also optimize on costs, right? So that is the value proposition that they're talking about. When we talk about high availability, we're just saying that we want to remain available, right, at all times. We want our application to always have some kind of response if we send a request. We want to remain available. But that the certain question here, the value proposition for horizontally scaling instances, that relates to elasticity, not high availability. All right. So very good. So that was touching on the first domain, 1.1. Make sure that you do go back to the exam guide and you're able to explain or articulate the benefits of the cloud shown here, right? So the one we just looked at was elasticity, but you're supposed to be able to know the differences between those terms. All right, so moving on to domain 1.2, which is all about cloud economics. And one important thing to understand is total cost of ownership. So whether we're operating in the cloud or we're operating on premises, there are certain costs that we need to be aware about. These costs are the what we need to pay for running and operating applications, right? So we have operational expenses known as OpEx. We have capital expenses known as CapEx. We have labor costs, which are mainly associated with on-premises operations. And then we have the impacts of software licensing costs. So if we map these two definitions, we can think about operational expenses as really the costs of running a data center, right? The costs related to power, taxes, maintenance, right? So that those would be, factors for on-premises operations. But OpEx could also relate to charges that you're, being charged in the cloud, right? So in AWS, we do have operational expenses, also known as variable expenses. And these would be the expenses of actually running cloud services, right? So that's OpEx, and then we have CapEx. So capital expenditure is, the expenditure related to buying physical hardware or buying equipment. And really, this is only an on-premises cost, right? So the cloud, one of the main benefits is that it allows us to trade capital expenditure for variable or operational expenditure because we don't have to invest in physical infrastructure or abide by long-term contracts, right? We also have labor costs, which are mainly an on-premises expense as well, right? So how much staff do you have to essentially pay to maintain and configure servers, right? So that would be the cost of labor. And then lastly, we have impacts of software licensing, which is what we also need to understand. If we migrate to the cloud, how do those costs change? Are we moving to an AWS managed licensing model? Um, are we importing existing software licenses to the cloud, right? So these are costs that we need to account for as well, right? So with that in mind, let's move on to the second question for domain 1.2. Right, we'll walk through it. We'll read the STEM again, the strategy that you need to take. Read the STEM, which asks which on-premises expense will be reduced if a company migrates their application to Amazon EC2, right? Elastic Compute Cloud. So dissecting that and pulling out the keywords, this was a pretty short question. So pretty much everything here can be referred to as a keyword in some sense. We're looking for what on-premises expense can we abstract when we move to a infrastructure as a service offering like Amazon EC2, right? So with that in mind, let's go ahead and read the responses and everyone can drop in their opinion here for what the correct answer is. So Max had a good question. Wouldn't labor costs fall under OpEx? In some scenarios, you might count labor cost as operational expenses, but when we're looking at, the value proposition and we're talking about cloud economics, we sort of like to separate the labor costs from the actual costs that it takes to run services in the cloud, right? So good call out there, but for this topic, we sort of like to separate them. So I think everyone has reached some consensus here. Very good job. So everyone, I think, has mentioned A, which is the correct answer, right? Server hardware costs, right? So Amazon EC2, again, allows you to spin up a virtual machine, which basically lets you abstract away the need to purchase physical hardware. And that's the correct answer here, right? Has nothing to do with Amazon EBS storage costs. That's still something that we need to pay for, given that we're using EC2, so we have block level storage. Storage backup costs, also something that we still have to account for, and cost of transferring data to the internet, right? If we're doing that, then we still need to pay for that, right? So the correct answer is the server hardware costs. Good job. Right. So again, jump back into the, I'm going to be jumping back and forth into this, but make sure that for the domain 1.2, subdomain 1.2, you are able to clearly understand and explain the concepts that are listed out here, right? So moving on to domain 1.3, which is about architectural design principles or best practices. And really the 4 design principles that we want to focus on for this exam are firstly, designing for failure. So essentially, when we have, disasters or something that occurs that can cause our application to go down, how can we design our application for failure or fault tolerance, right? Here we want to think about adding redundancy wherever we can. We want to understand the differences between a monolith, so a monolithic architecture, versus a decoupled architecture, right? So what are the benefits of decoupling your architecture, having loosely coupled components? We want to think about elasticity and what elasticity means and how it differs between elasticity in the cloud versus elasticity on premises. And then lastly, we want to be able to always think in parallel. So how can we sort of divide the task into multiple parallel processes, right? So these are really, for the cloud practitioner test, at least, what we want to focus on for domain 1.3. And we'll talk about each of them. So the first one we said was designing for failure. Again, here we want to try to add redundancy and avoid things like single points of failure. So we can already see from this architecture right here, this is sort of designing for failure in some aspects. And we can see that because it is making use of multiple availability zones, right? That's the first thing that it's doing here. And we will talk about the global infrastructure later on today. But because we're sort of distributing requests that are coming in to our ELB, right? That's our elastic load balancer. And an ELB, first of all, can detect whether any of its targets are unhealthy or unresponsive, right? So it does those instance level health checks. And if we face an availability zone level failure, let's say AZB goes down, the ELB can redistribute requests accordingly to the resources that are still up and running, right? So that's the first thing that we're doing here. We're making use of multiple availability zones. And remember that it is a high availability best practice to use at least 2 availability zones so that if one goes down, we can still remain available, right? The second thing that we're doing here is we are making use of a secondary database instance through Amazon RDS, the Relational Database Service. So RDS allows you to enable a feature called multi-AZ, multi-AZ, and we do like to keep this enabled, especially for production workloads, because what it does is that in addition to the primary database instance that it spins up in one availability zone, it's also going to spin up a standby secondary database in a second availability zone, so that if the primary ever fails or goes down, we can fail over to the secondary database, right? So that those are some ways that we're accounting for failures in this design right here. Basically trying to reduce those single points of failure wherever we can. The second thing we want to talk about is describing the differences between a monolithic architecture versus a decoupled one. Right, so a monolith is basically where we have all our application components running as a single application process, right? That's a monolith. We have a single maybe application server where all our layers are running on top of, all our application functionalities and components. And that means that if a single component fails, everything goes down with it, right? That's the problem with a monolith, is that our resources are really tightly coupled, in that um, we have tight interdependencies between the components, which means that it's very um, fragile in terms of, if again, if one of these components fails, everything fails with it. So we really want to take a loosely coupled mindset where we are decoupling our component our architecture components as much as we can, in order to improve that resiliency and, fail more gracefully. If there is a failure um, in one component, at least we're able to deliver functionality somewhere else, because not everything has failed with it, right? So that's what we want to understand. And we can take a look at this example here of a monolithic architecture, which has two Amazon EC2 instances, which are running our app servers, basically our application logic, but they're also running our database servers as well, right? Within the same virtual machines, we're running our database instances, right? And this is how we're sort of tightly coupling everything together, because if these instances go down, then the database goes down with it. And we definitely don't want that, because we definitely want the data that we store in our database to persist independent of the state of our instances, right? And that's why we'll decouple this architecture, and we'll make use of a specialized service to run our database, such as Amazon RDS, the relational database service. And now, if it happens that our app servers go down, we'll still have our data durably stored somewhere else, right? So that's one thing that we can do to decouple that architecture here. But there's also many other services that we can use for decoupling, specifically messaging services like Amazon SQS, right? The simple queuing service, um, as well as Amazon SNS, the simple notification service. We can use those to decouple our network tiers as well, right? So very good. That's thinking about decoupled architectures. The third thing we want to discuss is about elasticity, and how the cloud allows us to basically quickly scale out to meet our demand, right? So as opposed to running these servers on premises, where, let's say, our application goes viral and we need to quickly scale out, right? That's very hard for us to do on premises, because then we would have to purchase more infrastructure, right? Whereas within the cloud, we can actually base our scaling on objective data that's coming in, because we monitor data related to the resources we're using. For example, with Amazon EC2, we monitor things like CPU utilization, and we can use that as a scaling parameter to scale our resources out, um, again, using objective data, right? Dynamically acquire that compute capacity as we need. So just take note that when we talk about scaling out, we're talking about increasing the number of nodes that run our application, um, as opposed to increasing the size of the node, which would relate to vertical scaling, right? So that's not only can we scale out, again, we spoke about this when our traffic goes up, but the cloud also allows us to quickly scale back in, terminate, decommission those resources when we don't need them, because obviously we don't want to pay for resources that we're not using. And that goes within the notion, within the cloud, you only pay for what you use, right? So that's the benefit there. That's what we want to think. We always want to think about how we can incorporate that elasticity in order to meet our demand as well as optimize costs, right? And then lastly, parallel thinking is, we're looking for how we can sort of divide a process into parts that can operate in parallel, right? So essentially at the same time. For example, if we have 10 different messages that our application server needs to process. Maybe we'll place that in some kind of queue, and then, again, scale out so that we can have different application servers processing those messages at the same time, rather than one server processing all of those 10 messages sequentially, right? So that can be an example. Another example, when we talk about services like Amazon RDS, the relational database service, we also have this idea of read replicas, right? Read replicas, which essentially allow us to add additional read-only nodes so that we can offload read requests to additional nodes rather than overloading our primary database with a huge amount of requests, right? So going with something like read replicas allows us to improve performance, again, because we're scaling out, we're adding additional read-only nodes where users can send requests to. Whereas we did speak about RDS multi-AZ as well. So just be aware about the differences, right? Multi-AZ is when we're specifically looking for availability. So we're using multiple availability zones, and we can fail over to that additional secondary database instance when we need to. Whereas read replicas is when we're talking about improving performance, thinking in parallel, distributing requests across multiple nodes at the same time, right? All right, so with that in mind, let's move on to the question for domain 1.3, which asks, which of the following is an AWS architecture design principle? So that was the stem. Again, from the stem, we want to go ahead and pull out the keywords. Again, there's no need here because it's just a couple of words here. So we want to find out, we want to select from these options which of the following is an AWS cloud architecture design principle. Sorry about the slide deck here. It seems like there is an error here. So we're not talking about this question. This was the other question, right? I apologize for that. I'll send that to the team in charge of the slide deck. But we're looking for which of the following is an AWS cloud architecture design principle. So put your answers in the chat. Okay, we're getting a couple of answers, and thank you so much, chat support team, for getting to those questions. Again, if your question is not answered, they're gonna try to get it as soon as they can. It's just that there's a lot of questions coming in, so just be patient if you're looking for an answer. Okay. So a lot of us are going for some of us are going for B, some of us are going for D. So let's see what that is. Right. So again, we spoke about how we want to decouple our architecture. So remember, this is one of the main design principles that we want to focus on for this exam is implement loose coupling, right? We don't want to implement vertical scaling, right? Vertical scaling is where we're scaling up a single node, right? We're increasing the size of that node. Instead, we always want to try and lean for where we can implement horizontal scaling, where we're adding additional nodes. We're adding and reducing those nodes. We're incorporating that elasticity, right? In terms of monolithic design, obviously we don't want a monolithic design, and we don't want to implement single points of failure, right? So the correct answer is implementing loose coupling. Very good. So that is the end of our first domain around cloud concepts. Let's jump into security and compliance. So this is domain 2. Again, with regards to security and compliance, this is the third biggest domain that you'll be asked about on the test, right? Um, right, so it's 25% on security and compliance. And again, you can scroll down to the specific subdomains. For security and compliance, we have 4 subdomains, right? We'll talk about them in a second. But again, use the exam guide as that checklist where you can check things off and um, um, detect where you might be lacking in knowledge, right? So for the subdomains, which we just saw in the exam guide, they're going to be composed of the AWS shared responsibility model. So we have to understand what that is. We also need to be aware about compliance in the cloud. So in terms of the concepts, when we talk about compliance in the cloud, how can we achieve compliance and where can we look for certain reports around compliance? AWS access management capabilities. So what are the different ways that we can access the cloud? And then lastly, resources for security support. So where can we find additional resources for support around security and compliance? So we'll start with the AWS shared responsibility model. And really, when we talk about security, which is AWS's top priority, we always bring back the shared responsibility model. This is the first thing we look at. And basically, this tells the story that AWS is responsible for security off the cloud, whereas you, the customer, you're responsible for security in the cloud, right? So be aware about the differences in wording there, right? So it's basically both the responsibility of AWS and its customers to ensure that data and assets are kept secure and compliant, where AWS will essentially take care of everything from the hypervisor layer all the way down to the physical infrastructure that your applications run on top of. So for example, making sure that there is maintenance and security around these physical hardware devices, right? Making sure that the network infrastructure, the software infrastructure is all taken care of. Whereas you, the customer, you're going to be in charge of everything that comes on top of that, right? So your security in the cloud, for example, making sure that you're encrypting your data both in transit and at rest, making sure that you're applying the appropriate firewall configurations. So for maybe our EC2 instances, are we setting security group rules to ensure that we're only allowing traffic that needs to be hitting that instance, right? So for example, not opening up port 22 to the world, making sure that our operating system is patched, right? This is something that we need to also be responsible for in the case that we're using Amazon EC2, which is an infrastructure as a service offering, right? Making sure that we're basically patching that guest OS with the latest security updates. Making sure that we're applying the appropriate access control rules. So this is where another service called Identity and Access Management comes into play. And we'll talk more about IAM later on. So here, we really want to follow the principle of least privilege, where we're only granting access on a need-to-have basis, right? Only granting access to resources within our account on a need-to-have basis. If we have, auditors that only require read access, then we're not providing them with write access to a database. We're only giving them with the needed access that they need, right? And then lastly, the data that you store. So that's your responsibility as well. If this is medical related information that needs to be treated in some sort of way to maintain your compliance, then you need to be aware about that as well, right? You're responsible for how you deal with, what happens to be sensitive data in the cloud, right? So we need to understand what we're responsible for versus what AWS is responsible for. And this responsibility does vary depending on the service that you use. So this is also something important to understand, because if we're using a fully managed service like Amazon RDS, the relational database service, RDS takes care of things like patching, maintaining backups, right? So it with fully managed services, they take care of a lot of that undifferentiated heavy lifting of IT tasks that you would need to take care of if you're using an unmanaged service like Amazon EC2, right? So if we go back to the diagram on the previous page here, if we are using Amazon RDS, then this does not become our responsibility because, as we said, RDS takes care of patching the OS for us, right? Um, with Amazon RDS, it's very easy for us to enable things like server-side encryption, right? With just an option that you can set. Right? So we would be in charge of essentially making sure that we set the correct firewall rules and everything that comes on top of that, right? So that's what we would be in charge of with a service like RDS. And then, sorry, I went back there. And then if we also go to a further level of abstraction with serverless offerings, right? So offerings like DynamoDB and Lambda, these are serverless. And what that means is that there's essentially no server for us to manage whatsoever, basically meaning that even more of those tasks are offloaded to AWS. Because with serverless offerings, we're not deploying within a VPC, a virtual private cloud, right? We don't specify the networking configuration for a serverless offering, right? They are regional constructs that automatically incorporate things like fault tolerance, encryption, um, um, and yeah, so we wouldn't need to take care of things like um, firewall rules or the OS. Essentially, with serverless offerings, our responsibility falls sort of within those two at the top, right? Um, so we need to be aware about this, how this responsibility varies between services, okay? So let's go through a question walkthrough for 2.1, which asks, which of the following is the customer's responsibility under the AWS shared responsibility model? So again, we want to pull out the keywords. Here, the keyword would be customer's responsibility. So let's look at the responses. What does everyone think the answer is? All right, so we will try to get to all of your questions. Just be aware that this is more of an informational session about the exam. So sort of just related to how you can structure your studies and going through a couple of questions and just being aware about what the domains are for this test. We're not going to dive deep into how every service works, right? That would be sort of what you need to go through in your own time. This session is more of an informational session around the cloud practitioner test, right? So although my chat support team can answer most of the questions, just be aware about that. Okay, so let's take a look at the responses. We're getting mainly C's here. Yeah, mainly C's, which is the correct answer. So very good for those that went for C, which is patching EC2 instances. Again, if we are dealing with an infrastructure as a service offering, right, an unmanaged solution like Amazon EC2, right, these are virtual machines. You spin them up, but you have full responsibility over them, right? They're unmanaged. So making sure that the guest OS is patched is entirely your responsibility. Not related to physical security, that would be AWS. Everything related to physical security, the underlying infrastructure or the network infrastructure, right? The entire AWS global infrastructure, the software infrastructure, the network infrastructure, the physical security and maintenance of the servers, that's all AWS, right? Right, so everything, if you're dealing with EC2, now you would need to make sure that those instances are patched. Right, so very good. If you can take away, two things from the shared responsibility model, or really one thing, it would be to remember these two things. So as a customer, you're responsible for security in the cloud versus AWS is responsible for security off the cloud, right? So if you can just remember those two things, it can really help you on the test for identifying the correct key, okay? And yeah, by the way, if it wasn't already dropped, you can always go to the shared responsibility model page to get that diagram again, right? So everything is pretty much explained here. So let me just drop that in the chat so that you have it. There you go. All right. So moving on to domain 2.2, which is around cloud security and compliance concepts. And here, for the cloud practitioner test, we want to understand where we can find compliance-related information. And the service they're looking for, if they ask you, where can we find information related to compliance, like reports, the answer would be AWS Artifact. So AWS Artifact, if we can get a link as well from the chat support team, AWS Artifact is really your one-stop shop for on-demand access to AWS security and compliance reports, right? AWS Artifact, right? So with Artifact, we can access all of AWS's auditor-issued reports, and you can also use it to review and accept your specific agreements for your organization's accounts, right? You can deal with all that compliance within the Artifact service, right? So AWS Artifact, thank you, Zachary, for dropping that link. Also, there's AWS compliance programs, so you can look into the different compliance programs that AWS supports, things like GDPR, ISO, SOC, right? Different HIPAA, right? Different compliance programs that AWS is audited against for different services that we offer, right? We also put that in the chat as well. Right, so that's where we can find compliance-related information. Just remember, AWS Artifact is where we can find information and where we can review and accept certain agreements with AWS. That would all be within the Artifact service. But in terms of compliance and security concepts, we also need to understand how we can achieve compliance and security ourselves. So what are the different ways that we can explicitly achieve this compliance that we're looking for, right? And we talked about a few. So the first way would be to make sure, for example, that you're applying encryption. So both data encryption at rest as well as in transit, right? So at rest would mean that your data is encrypted in AWS at rest, wherever it's stored. And then in transit would mean that we have encryption from when we're transferring data, let's say, to AWS. So we have some kind of encrypted channel where data can flow over, let's say, HTTPS, right? So making sure that our data is encrypted both in transit and at rest becomes a big factor there. Secondly, we spoke about access controls, right? So making sure that we're applying the appropriate access controls through our IAM service, Identity and Access Management, following the principle of least privilege, right? So those would be two primary ways in which we can, achieve that level of security and compliance that we might need. And then the third way would be through our logs. right? Implementing, auditing measures, making sure that we are reviewing our logs. So we have different logs. We have CloudTrail logs, right? So CloudTrail. We also have things like VPC flow logs, right? So these logs provide us with additional information about the traffic that are coming into our account, essentially, that are in our application space. So CloudTrail is a service that automatically tracks every single API call made in your account. So you can always go back and view, for example, who made the call, when the call was made, what the response was. VPC flow logs will basically maintain a record of every packet that flows in and out of your VPC. That would be on the layer 3 or layer 4 um, um, traffic level. So sort of works like Wireshark in some sense if you've used Wireshark in the past, but not exactly. But it gives you IP related information. And then CloudTrail would be more related to the API calls that were made, right? And then we also have our CloudWatch logs. So CloudWatch, we'll talk more about CloudWatch later on, but be aware about the different ways that we can, achieve that level of compliance that we might need. So let's go through a question for that subdomain, which asks, which service enables risk auditing by continuously monitoring and logging account activity, including user actions in the AWS Management Console and AWS SDKs, right? So pulling out the keywords here, right? Auditing, continuously monitoring and logging. I would also include account activity in there as well as user actions, right? Those seem like keywords to me, right? So what is the service that enables that? Feel free to drop your answers in the chat. So again, just to clarify, the recording for today is not going to be distributed, right? If you do see that the session is being recorded, that's only for internal QA purposes. Also, the deck will not be distributed as well, right? We're not distributing any vouchers um, uh, or slide decks or anything like that, right? So let's go ahead and take a look at the responses here. So I do see that most of you are going for B, right? Which is the correct answer. So perfect, right? Um, Someone asked, what are the AWS SDKs, right? The SDKs are our software development kits. So we have essentially multiple ways that we can interact and manage resources in our account, right? The AWS Management Console is one way, which is the web-based interface. But then we also have programmatic mediums as well, such as the software development kits. Our SDKs are basically APIs for different programming languages. So if you're developing with Java, Python, JavaScript, let's say, and many different languages that are supported, then you can interact with resources as part of your application code through our SDKs, right? But it doesn't matter how we're interacting with resources. Just remember that every action we carry out in AWS is always going to be mapped to the same REST API call in the backend, right? So every one of those API calls are going to be tracked and monitored by the CloudTrail service, no matter how we made that call. So just to clarify things there. So very good. Those that said CloudTrail, that is the correct answer. Let's move on to domain 2.3, which is on access management capabilities. And so we touched on this a little bit when we were talking about IAM, right? Identity and access management. So what is IAM? IAM is the service that allows us to apply authentication as well as authorization within our account, right? So essentially, identity, we're talking about authentication, right? Who are you? And then access management is related to the authorization aspect that it provides. basically when we validate who you are after being authenticated, what can you actually do, right? What are the actual actions you're authorized to carry out? And that's what the identity and access management service is all about. Now, there's a couple of things we need to understand for the test related to IAM, specifically related to how the root user differs from other IAM users that we create. So it's important to understand that when we create an AWS account, right, how do we create that account? Well, we have to provide an email address, a password, and also a credit card, right? For any services that you use, they'll be charged on that card if you go over the free tier, let's say, right? But we need to supply an email address and a password. So when we create that account, and we log in with the email address and password that we used to create that account with, we're essentially logging in as the root user. And it's important to understand that this root user has unrestricted sort of godlike powers within that account, right? So this root user, if the credentials were ever exposed, there would be no way for us to limit the permissions that that root user account has. And that's why it's really best practice to always limit the use of the root user as much as you can, right? So we don't want to use the root user for day-to-day activities. Instead, what we want to do is when we create that account, as the root user, we'll head over to the IAM service, and from IAM, we will create an IAM user, and we'll grant that user with administrative privileges, and then we will log in and use that admin user for any day-to-day tasks that we need to carry out instead of using the root user account. That's a security best practice, because if, for example, the credentials for this user were exposed, we can always log back into the root and limit the permissions that that account has. But we can't do that on the root user, right? So we wanna limit the use of the root user for day-to-day activities, right? After doing so, we want to make sure that we're locking away root user credentials so that they're we're enabling things like MFA, multi-factor authentication on the root user, right? So that there's an additional level of security if anyone tries to access it, right? And then we also need to understand the different features of IAM, right? So the different features are users, groups, roles, and policies, right? So we already spoke about users. Users are basically entities that we create in IAM that are granted permanent credentials in our account, right? So users, as we said, will be granted permanent credentials. And what that means is that a user's credentials would never expire unless explicitly expired, right? Otherwise, they will not rotate automatically, right? They're given permanent credentials. And we create users for the different maybe employees on our team that are accessing the same account, right? So remember that when we create users within an account through IAM, they're all logging into the same AWS account. They're just going to have different permissions within that account, right? And we'll talk about how we set those permissions in a second. So know what a user is. A group is just a collection of users that share similar characteristics. So maybe these can be all developers. And so instead of individually managing permissions for each and every developer, we can create a developers group. So we have a devs group, and then we can simply set the permissions on that group. So groups basically allow us to simplify managing permissions for users that share similar characteristics and therefore need the same permission sets. We use groups. And then roles are the primary way for us to grant temporary permissions in our account, right? Temporary credentials in our account. So we usually draw a role as a hat. It's like a hard hat that you wear to gain those temporary permissions until you take that hat off, essentially, right? So roles provide you with temporary credentials that automatically expire because there's a sort of session token, and by default it's an hour long, but you can configure that if you wanted to. But just remember that roles are the primary way for us to grant temporary permissions. They're also the primary way for granting a service permissions to interact with another service. So for example, in the case that we have an EC2 instance that's uploading image files to an S3 bucket, right? So we're using the S3 service and we're also using EC2, right? By default, EC2 is not going to have permissions to upload or interact with S3. So the way we provide those permissions is by allowing this instance to assume a role, essentially, right? So those are users, groups, and roles. Now, how do we set the permissions on those user groups and roles? Well, that's where these policies come into play. So policies are the JSON-based documents where we set either the allow or deny permissions, and we apply these policies to either users, groups, or roles, right? So these are IAM policies. They can be applied to either a user, a group, or a role, right? Policies are how we basically write out those permission sets, right? So with that said, and I hope those questions are answered in the chat, let's move on to the question for domain 2.3, which asks, which of the following can limit Amazon S3 bucket access to specific users? We have an S3 bucket. What do we want to do? Well, we want to limit access to that bucket, right? So how are we going to do that? Drop your answers in the chat. What do you think? Yeah, so let's see what everyone is saying. Okay, the answer is C. Everyone's saying the answer is C, and correct. The answer is in fact C. Right. I was just looking at my time. I forgot I was in Eastern time. It's 11 a.m. I thought I thought we just ran out of time there. But yeah, so it's about 10 a.m. the top of the hour. We'll go through the rest of this domain and then we'll take a break and then we'll continue on from domain 3 after the break. So the next domain is around resources for security support. And it's always important for us to understand where we can find support and how we can achieve that security, right? Sorry, 1 second, I dropped my pen. Right, sorry about that. Okay, yeah, so we were talking about, how can we achieve that security? And when we're talking about network level security, we need to understand a couple of things. So we need to be able to understand the differences between security groups, network ACLs, right? So these are two things that, these are two measures that we can apply within an Amazon VPC, right? It's a virtual private cloud. And a virtual private cloud is just a private network that you create within the cloud where you can, launch the resources that you need in a network that you define. So you set things like the routing rules and, everything that you need within your private network in the cloud. Now, there are security groups, and security groups act as virtual firewalls for your instances, right? So for your Amazon EC2 instances, they dictate essentially what traffic is allowed to hit your instance and also what traffic can go outbound. So they manage inbound and outbound traffic to your instances, right? They act as those firewall rules that you can set. And then network ACLs, these act as virtual firewalls for your subnets, right? So remember, in terms of the architecture, we have our VPC, right? Amazon VPC, right? Our virtual private cloud, and our VPC lives within a region. So for example, let's say this is US East 1, which is North Virginia, right? We have our VPC. And then within our VPC, we said it's a high availability best practice to make use of multiple availability zones. So maybe we're running across 2 availability zones or 2 AZs, right? So availability zone A and availability zone B, right? And then within our AZs, here's where we launch our subnets, right? So we can have maybe a public and private subnet in each availability zone, right? Public and private subnet. And then within our subnets are our EC2 instances, right? So we can have EC2 instances within those subnets. Now, it's important to understand that when we launch an EC2 instance, we launch it within a security group, right? So this is the public, one of our private subnets, right? Private subnet, right? And around our EC2 instance, we have our security group, right? So we launch it within a security group, and then around our subnet, we have our network ACL, right? So this would be the NACL, the network ACL, right? So it's important to understand the differences between these. The security group acts at the instance level, whereas the network ACL acts at the subnet level, right? And it's also important to understand that security groups are stateless. Sorry, my mistake. Security groups are stateful, whereas network ACLs are stateless, right? Stateless. They perform stateless packet filtering. And what this means is that with network ACLs, they sort of don't have a memory of the packets that are coming in, right? Stateless, meaning that if we allow some kind of traffic into the network ACL, we also have to explicitly set a rule that allows it outbound as well, right? So if we allow something in, we also have to explicitly allow it out. Whereas security groups are stateful, meaning they sort of have a memory of the packets coming in. So if we allow some traffic into our security group, by default, it's automatically allowed back out. We don't have to explicitly set a rule for that. So just remember those things. Security groups are stateful and they act at the instance level, whereas network ACLs are stateless. They act at the subnet level. They both act as virtual firewalls where we can set inbound and outbound rules, depending on security group for the instance, NACLs for the subnet, and then we also have there we go. We also have to be aware about AWS WAF. So AWS WAF is our web application firewall. So with AWS WAF, we can set what are known as web ACLs or web access control lists. And this is mainly intended to help us protect against malicious requests on the application layer, right? So if we have things like cross-site scripting attacks or SQL injection attacks, we can have basically web ACLs that are sitting at the edge. That's where they sit. They don't sit within the VPC. They sit outside the VPC at the edge, and they can basically filter out these malicious requests, right? So we can protect our web apps against those kinds of application level threats. Now, other than that, we also need to be aware about other security related services. And again, this isn't a class that we dive deep into each one, right? We just need you to be aware about what you need to know for the test specifically. So things like AWS Config. AWS Config is a configuration management service that allows us to manage and audit the configuration of our resources, right? So basically, we can specify some kind of desired state, maybe for our EC2 instances, we always want to make sure that we're blocking traffic on port 2022. So we can create a config rule around things like that. And then AWS config continuously monitors to check if any resources violate that rule, right? So it's a configuration management service. We have Amazon Inspector, which basically allows you to run security assessments across your EC2 instances, and it generates a list of vulnerabilities that it finds, right? I would read the fact page on Inspector to learn more about it, right? Trusted Advisor is a service that runs a set of automated checks to make sure that you're following AWS best practices. So it runs checks against areas like cost optimization, performance, service limits, fault tolerance, and there's also security checks as well, which it would run for you. And we need to understand that with AWS Trusted Advisor, depending on the support plan that you use, the number of checks that it runs will differ, right? So we have multiple support plans, which we'll talk about later in our billing and pricing domain. But the number of checks that it runs automatically for you in your account will not be the same if you're using like a basic plan versus an enterprise plan. And then Amazon CloudWatch is really our foundational service for monitoring performance-related metrics and logs, right? So we can gather all our metrics, view our logs within Amazon CloudWatch. Now, other than native AWS services and tools, you can also go to the AWS Marketplace, which is a digital catalog of solutions from thousands of vendors and developers around the world who have basically placed their own homegrown solutions on our digital catalog, which you can consume as a service. So in terms of security and compliance, we have a lot of different security offerings on the marketplace from vendors like Cisco or Palo Alto, right? Different VPN related offerings and whatnot. So you can also make sure you are aware that we can utilize the marketplace for third-party security tools and software appliances as well. Right? So with that said, let's go through a question and then we'll take a break. Question 2.4, which asks which AWS service or feature can be used to prevent SQL injection attacks. Again, read the stem, pull out those keywords which are preventing SQL injection attacks, and then read through the responses and drop your answers in the chat. All right, let's take a look. So a lot of you have agreed on an answer. So the correct answer is AWS WAF. Very good, right? The web application firewall is that service that allows us to protect against application layer attacks such as SQL injection attacks. So very good. Okay, so be aware about the differences there. Again, security groups and network ACLs, these act on layer 3, layer 4 network traffic, which they're filtering out. Not application layer traffic. IAM policies are, specifically within your account. What are the different API calls that can be called to different services, not to protect against things like SQL injection attacks. Right? So very good. With that said, let's take a break. So go grab a coffee, and we'll be back in, or whatever you like to drink, of course. And we'll be back in about 10 minutes, right? So it's 10:15 right now. We will be back at 10:25, and we'll start at domain 3. right? So thank you all so much, and I will talk to you all soon. Thanks. All right, welcome back everyone to our session on the Certified Cloud Practitioner, our exam readiness session. Hope everyone is um, back and ready to get started on the second half, right? So up until now, we spoke about domains domains 1 and 2, and now we are going to continue on to our third domain, which is around AWS technology. Okay. All right, perfect. So I think my voice is coming through. Yes, all is good. All right, let's continue on with domain 3. So on domain 3, we want to understand, firstly, the AWS core services, which is domain 3.3, but this is really what the chunk of the domain would be about. Understanding, the services that relate to compute, storage, networking, and database, right? So we'll talk more about that. Also, how we can interact with resources in our account. What are the different ways that we manage resources in our account? Domain 3.2, we'll talk about the AWS global infrastructure. So we already sort of touched on this idea of regions and availability zones. So we'll talk more about what they actually are. And then also resources for technology support. So if we're dealing with a service like Amazon EC2, how can we find resources such as API documentation or resources that allow us to for supporting our use of that service, right? So we'll talk about methods of deploying and operating, and really the three primary methods. There's 4 listed here, but the 3 primary methods which you would use to interact with services in your account are through the management console, right? So again, the management console is our web-based interface that gives you a user-friendly way of interacting with any service that you need and deploying resources in the region that you choose, right? Um, Management console is great for having that visual representation of the resources that we deploy into our account, and viewing things like statistical graphs in CloudWatch and monitoring the resources that we deploy. But as our business starts to scale, we need more automated ways to deploy and provision resources in our account, let's say, right? We need programmatic ways for interacting with resources rather than just going into the console and doing a bunch of clicking, right? And that's why we have the AWS CLI. So the command line interface is a tool that you can install where you can simply manage your resources from your terminal or PowerShell if you're using Windows. So we can run ad hoc commands to resources from our terminal, right? And then we also have the SDKs, which we spoke about. So these are the software development kits or the specific APIs that are opened up for different languages, and I'll actually take you to this page here for the SDKs because I know someone asked about it. So AWS tools, if you just search up AWS tools, you should get that link here for SDKs and programming toolkits. Put this in the chat as well for those developers in the room. So if you scroll down here under SDKs, you will see, the specific software development kits that we support for different programming languages. You can jump into, the one that you usually typically use and install. Look into the instructions of how we actually install those SDKs, right? So again, SDKs would be used as part of our code when we're interacting with services. And then we also have infrastructure as code. So infrastructure as code services like CloudFormation, right? So CloudFormation, AWS CloudFormation is our infrastructure as code framework that essentially allows you to write up your infrastructure using code, using JSON or YAML formatted templates. We can have these templates that we can reuse and provision our infrastructure in a repeatable and consistent manner, right? So AWS Cloud Formation, or when we're using infrastructure as code, it's basically calling those different APIs for us, right? Provision EC2 instance, launch an S3 bucket, so on and so forth. But we've defined all of this using a declarative template, using code, right? So those are the different ways that we can interact with, we can provision resources in our account, right? So you need to be aware about these different methods. Now we also need to be aware about the different cloud deployment models. So there's three different models here. Firstly, we have cloud native, also known as all-in cloud. This is basically when all of your workloads and all of your data live and run in the cloud, right? That means you're all in cloud. On-premises would be the opposite. So basically all your data and resources and workloads run on premises. We might be using some kinds of virtualization software to help us utilize our resources more efficiently, but essentially everything is running on premises. And then we have the hybrid model, which is sort of a combination of both, right? Some of our workloads running in the cloud, some of them running in premises, and then we have some kind of communication link between AWS and your on-premises data center that allows you to transfer data back and forth. And there's many reasons why you might take a hybrid approach. Maybe you want to migrate to the cloud, but there are some workloads that need to remain on premises due to some compliance regulations, which state that these are sensitive workloads that need to remain on premises, let's say. So you can take a hybrid model in that case, right? So different those are the three different models for the cloud. And so we spoke about hybrid, and how can we actually incorporate that communication when we're dealing with hybrid architectures, right? There's different ways that we can form that connectivity. Firstly, we have solutions like AWS site-to-site VPN, right? So with a site-to-site VPN connection, we have a customer gateway on your on-premises network. We have what's known as a customer gateway. And then we have a virtual private gateway in AWS within your VPC. And then that allows us to basically form or create an IPsec tunnel, right, or a VPN connection where data can be transferred back and forth through this IPsec tunnel, right? So your data is encrypted and it's and we can create that virtual private network connection between AWS and your on-premises network. Now, for some cases, you might need a physical fiber line instead of doing something like a wireless connection, such as VPN, which goes over the public internet. Ultimately, it's just encrypted. But sometimes we need a more consistent way of transferring data back and forth, because with VPN, we can only achieve up to some limit of throughput. Sometimes we need, a physical fiber line connection, and that's where AWS Direct Connect comes in, which gives us a predictable network performance because we do have a dedicated private line that's only for our use. We have predictable throughputs, right? And it's also, we can also encrypt our data through that line if we want to as well, right? But just know the differences there. Direct Connect is when we're transferring large amounts of data on a day-to-day basis. It's really the best solution for those hybrid architectures, where we have a lot of data transferred back and forth. Not the best solution, but in a lot of scenarios, it might be the most optimized, right? And then we have an internet gateway, which is sort of not related to connecting on-premises to AWS. This is related to connecting your VPC to the public internet in general, right? In order to do that, and in order to enable inbound and outbound traffic to the internet from our VPC, we have a component called the Internet Gateway. Right, so that's the network components you would need to attach to your VPC to enable that inbound and outbound. It basically acts like a doorway to the public internet. So let's go through a question, walk through this one on 3.1, which asks which components, and by the way, for the remaining questions, sorry, I forgot to note, the Q&A is getting quite cluttered because we are a lot of students. So if you could just answer it in your head, we will go over the answers instead of everyone dropping it in the chat because it is getting cluttered. So if you just answer it in your head, and then we will go over the answers, right? So which components are required to build a successful site-to-site VPN connection on AWS? Here it's asking you to select two. So remember, read the stem correctly. It's asking you to select two correct responses. So it's a multiple response question. And these are the keywords, right? We need a site-to-site VPN connection, and we're looking for the appropriate components that are required to create that. So think about it. Think about what we can eliminate here, and think about the different answers in your head, and we will go through them in a second. Okay, so going through this question, the correct responses here are, as we spoke about when we were talking about the site-to-site VPN connection, right? For that, we require a virtual private gateway, and that would live in your VPC, essentially. So we create a virtual private gateway. And then we have a customer gateway that would live on premises. So this would act as a physical hardware device that you have on premises, but we'd configure it within our AWS console. We'd configure that device as our customer gateway. And by doing so, we can then create this site-to-site VPN connection. So those are the two components required to create that, right? Not the internet gateway. As we said, the internet gateway enables inbound and outbound traffic to the internet. Not the NAT gateway. So the network address translation gateway is required to enable indirect internet access to our private resources. So if we have private instances in our private subnets, how do we grant them access to the internet? That would be by using a NAT gateway. And then a transit gateway is when we have, sorry, hundreds of VPCs that we would like to connect together. We can use a transit gateway as sort of a hub and spoke model for creating, routing rules between these, hundreds of VPCs, right? So it doesn't really fit into the question here. All right, so perfect. Now let's talk about domain 3.2, which is all about the AWS global infrastructure. And to understand, what the global infrastructure is comprised of, let's actually break this down into a hierarchical diagram, right? So we start with this idea of a region, right? An AWS region. And an AWS region is just a geographical location around the world where AWS services are accessible from, right? So you might have seen me use US East 1 as the region code, and that would be for North Virginia, right? So that would be, the North Virginia region. And regions are composed of multiple availability zones, right? So each region has multiple availability zones. So in North Virginia, there's actually 6, right? But I'm just going to draw out 3 here. So let's say availability zone A. Let me actually do that in a different color. Right? Availability zone A, availability zone B, and availability zone C, right? So every region is composed of multiple availability zones. So what are availability zones? Well, availability zones are a cluster of one or more data centers, right? So we have one or more data centers within an availability zone. So this availability zone might have two, this one might have two, and then this one might have, let's say, three, right? And each availability zone has redundancy in its components for networking, power, and connectivity, which basically allow it to operate independently from any other availability zone in that region. And that's why we said that for high availability, we want to make use of at least two availability zones because they're not dependent on one another. They're actually separated by um, hundreds of kilometers apart, so they're pretty far away from each other within the same region. Um, basically, as we said, if one availability zone goes down, let's say, that's not going to affect the other availability zones in that region, right? Um, and then other than regions and availability zones, we also have edge locations. So let me draw this out in this color here. So I'm just going to draw them out like that. So around regions, we have many edge locations, and we actually have over 410 around the world. But edge locations, these are utilized by our CDN, our content delivery network, which is, if many of you may know, it's Amazon CloudFront, right? Amazon CloudFront is our CDN that utilizes these edge locations to basically cache static data closer to the end users making those calls, right? So these edge locations sit at the edge, right? So they're closer to the end users that are making those calls, and so the edge locations are basically used to cache frequently requested and static data closer to the users making those requests in order to lower latency, right? So be aware about the differences between these different components. You can also head over to infrastructure.aws. So I'll put this in the chat. Right? And they did change the layout of the page here recently, but you can get a better idea about, within each continent, how many regions and availability zones live within each one, right? You can also read about the benefits of the different components that we spoke about. It's not just regions, availability zones, and edge locations, but for the cloud practitioner test, those are the ones that you need to be aware about primarily. If you go to the overview page, you will see that we have 26 regions around the world with 84 availability zones and over 410 points of presence. So points of presence and edge locations, those terms are used quite interchangeably because points of presence is sort of the umbrella term for edge locations as well as regional edge caches, which just means that in 13 regional locations around the world, data can also be cached. So they just use the points of presence term as the umbrella term. But yeah, and then you get a nice graph here as well. So be aware about the differences between availability zones and regions and edge locations. Know the hierarchy, right? A region is made up of multiple availability zones, and then each availability zone is a cluster of one or more data centers. And then edge locations are basically dispersed around regions, and they sit closer to the end users making those calls so that we can reduce latency for delivering static data, right? So with that in mind, let's go through a question. Which aspect of the AWS infrastructure enables global deployment of compute and storage? So with that in mind, let's extract the keywords here. We're looking for one of the AWS infrastructure components that enables global deployment of compute and storage, right? So again, feel free to just answer this in your head, right? Of course, if you have any questions, make sure you note them in the chat. Any questions about the questions that we go through, right? Right. I just saw a question from Thang Tran. Just to answer your question on what's the difference between a local zone and an edge location. So a local zone is used to basically extend AWS services like compute, database, and storage closer to the end users themselves. So local zones also sit in highly populated cities like Boston, different cities around the world where there's high population, and those are used to deliver services like compute, storage, and database, whereas edge locations are primarily used to cache static data, right? So that's mainly the difference between those two. So going into this question, which enables global deployment, right? The correct answer here for everyone, a lot of people noted B, which is region, and that is the correct answer, right? So the keyword here was global, right? So the only one that provides global deployment of compute and storage are regions, right? If they said in the question zonal deployment, then it would be availability zones, correct? Okay. Okay, moving on to domain 3.3, which is about core AWS services. And again, for this domain, you need to understand the different services that live within these four functional domains, which are compute, storage, networking, and database. So we're going to go through a couple of slides here. Again, we're not going to talk about each service in a deep dive, right? This session is just informational. You do need to go into these, and learn about how they, what they do in more detail. But we'll talk about them quickly. So we spoke about Amazon EC2. So this is for compute, right? We spoke about Amazon EC2, which is Elastic Compute Cloud, allows you to provision virtual machines. So basically servers that run in the cloud, but you have full control over them, and you can basically do anything that you can do on a standard server that you would run on premises, except these are running in the cloud, so you have secure and resizable capacity on demand as much as you need, right? We have AWS Lambda, which is our event-driven serverless compute engine. So AWS Lambda, you simply provide your code, and then Lambda runs your code in response to events, right? So it's basically going to provision all the compute infrastructure needed to run your code. And then once your code finishes running, it's going to decommission everything. And that's one of the benefits we get from serverless services like Lambda, is that we don't pay for idle resources because it only runs when you actually need that code to run, essentially, right? Elastic Beanstalk is an infrastructure management tool. So Elastic Beanstalk allows you to simply upload your code, and then Elastic Beanstalk takes care of provisioning all the infrastructure needed to run and manage your code. So with Elastic Beanstalk, it's not only provisioning the compute, it's provisioning other components as well, like the Elastic Load Balancer. It actually provisions EC2 instances. So that's what Elastic Beanstalk uses, right? It will provision, let's say, an ELB, and then it will, set that as targets to EC2 instances which run your code. You can also specify whether you want to add a database layer and so on, right? Whereas Lambda is serverless. We don't have EC2 instances running in our account. It just runs your code in response to events, and then that's it, right? And then we have Amazon ECS, which is our Elastic Container Service. So ECS is basically for when you want to run and scale Docker containerized applications. You can do that using Amazon ECS. Now that was compute. Looking into storage, you need to understand the differences between object level storage, block level storage, file level storage, and what services are used for each one, essentially, right? So when we talk about object level storage, we're talking about Amazon S3, and I would recommend reading the fact page on S3. And then block level storage is through Amazon Elastic Block Store. So every EC2 instance that we provision has a root device volume, basically where our OS and additional applications are stored. And that would be defined by the AMI that we choose, the Amazon Machine Image, would define what Elastic Block Store we use, essentially. But with EC2, we use block level storage, and that's delivered through the EBS service. Now, if we have, let's say, many EC2 instances across regions or across availability zones or even across VPCs or accounts that all need to share the same file storage, then we can use the solution like the Elastic File System, which allows us to create a file storage that can be shared across thousands of instances at the same time. And then we have Amazon S3 Glacier, which is just a different flavor of S3, but this is for archival storage. So for long-term backups and things that you need archived, you can store them in Glacier, and you're going to be paying much, much less for storing them as archives in Glacier. And it also gives you secure and durable storage. So know the differences between the storage services that are provided. Now, when we talk about networking, again, really the most foundational networking service to be aware about is Amazon VPC, the virtual private cloud. We explained what this is. We explained what Direct Connect is. Know that this provides you with that physical fiber line. Transit Gateway, when you have hundreds of VPCs that need to be connected together. So we can create a hub and spoke model where we have a centralized way of managing routing rules for all of these VPCs, right? So it simplifies our network infrastructure with Transit Gateway. And then Route 53 is our global DNS service that deals with things like DNS resolution, of course, but it's built for the cloud. So it provides you with different features, like you can register your domain names directly from Route 53 and configure different routing policies as well. Right? There's various routing policies that you can choose from to optimize based on high availability or latency and things like that. Right? So Route 53 is our global DNS service. And then lastly, in relation to databases, we spoke about RDS a little bit. So RDS is our relational database service. It basically allows you to provision and run and scale relational databases in the cloud based on 6 database engines that you can choose from. So there are 6 relational database engines that RDS provides. There's MySQL, PostgreSQL, MariaDB, Microsoft SQL Server. What did I forget? Oracle. And then the 6th one would be Amazon Aurora, which you see on the slide here, right? So Amazon Aurora is one of the options, one of the relational database options you can spin up with RDS. And Aurora is basically Amazon's relational database that's built for the cloud. So it's built to take advantage of cloud scale. It's built to take advantage of the global infrastructure. And that's why it gives you an enterprise level database offering that can achieve 5 times the throughputs of MySQL, so standard MySQL, and 3 times the throughput of standard PostgreSQL. Right, so it's both MySQL and PostgreSQL compatible, but it can give you higher performance, higher throughputs because it's built to take advantage of the cloud. Now, DynamoDB is our NoSQL key value and document database. It's also serverless. So if you're looking for high amount of read and write throughputs, DynamoDB is really optimized to scale out because it's non-relational and it's serverless, so you don't have to worry about any servers. Yeah, there was another point, but I can't remember it now. Yeah, so it's our serverless non-relational database engine, right? And then oh yeah, the point that I was missing was it can achieve single-digit millisecond response times, so it's pretty fast, right? Single-digit millisecond latencies. And then Amazon Neptune is when you need a graph database that's built for the cloud. You would go with Amazon Neptune. So for things like social media engines, recommendation engines that use the actual relations as their data, right? Amazon Neptune allows you to build those graph databases for the cloud. And if you go on databases on AWS, you can read more about all of our databases. So there's actually 15 purposely built database offerings, engines that you can choose from, and you can read more about them on this page here. So I'll just drop that link in the chat. Throughput means throughput means how many reads and writes you can achieve per second, right? Your throughput, where that question was asked. Right. Yeah. So for anyone that has any questions, please drop it in the chat. Again, I went through those services, but in actuality, this session is we're not supposed to talk about each and every one in detail. We're just supposed to present to you what could be asked to you in the exam and what you should know about, right? So I really do wish that I had the time to dive deep into each and every one and had more time to hang out with all of you, but that's just the nature of this session here, right? I'm actually going into them more in detail than I actually should because of time constraints and just the nature of how this session should be, right? But please feel free to drop any of your questions in the chat, and someone will get to it. Right? So let's go through a question here, which asks, which AWS service can most efficiently import exabytes of data to the AWS cloud from an on-premises environment, right? So reading that stem, we want to pull out those keywords which state we want a service that can most efficiently import exabytes of data to the cloud from on-premises, right? So we're moving data from on-premises to the cloud, but this is exabytes of data, and we need the most efficient data transfer solution, right? So let's look at the different options here, right? Think about it. And although we didn't specifically talk about data transfer options previously, right, we're going through this question because, again, this could be asked in the test, right? So you should know about these different services. Yeah, so Diana, they'll mainly in this exam, it's mainly basic questions. So in terms of networking as well, you're not going to get questions that are too integrated or detailed, right? It's mainly going to stick to the basic high level stuff on this test, right? Okay, so very good. The correct answer is Snowmobile. That's the only exabyte scale data transfer solution. So AWS Snowmobile is an actual 14-wheeler truck that drives to your data center. It's just packed with storage modules in the back, and you simply wire it to your local area network. You transfer your petabytes of data that you need, and you can have multiple snowmobiles as well. You can order multiple snowmobiles. Um, and then it will drive back to the region of your choice and transfer it to the service that you need. In most cases, Amazon S3, right? So that's the only exabyte scale solution here, actually. So that would be AWS Snowmobile. And then 3.4 is about technology support. So it's also important to know where to find resources for support around the services that we use, right? And the very first place is, for many, would be service documentation. So you can find existing forums, white papers, API docs, even AWS blogs to find the answers that you might need, right? So documentation is available to everyone online. Um, you can view you have account-specific support. So actually, let me just show you an example of point one, which is documentation. So if you go to Amazon EC2 user guide, or you search, let's say, documentation, Even if you just search for the service name, not this one over here. Let's see. Yeah. So if you search docs.aws.amazon.com, you just need to enter the specific service name that you're looking for, and that should take you to the respective documentation related to the service. So if I put up S3 here, right, that should take me to the S3 related documentation, like the user guide and the API reference and so on, right? So I'll put this link in the chat. You also have account-specific support. So from the support console and the AWS Management Console, we can submit account-specific trouble tickets to get help from the AWS support team. And here, the level of your support plan would dictate, what kind of support you get. So I would also recommend going through that support plan page to understand what levels of support are available for each of those 4 plans. And we'll go to that page later on domain 4. But you do have account-specific support. You can also leverage the AWS Partner Network, or APN. This is made up of all the companies that are recognized partners of AWS. They could be training partners, migration partners, managed service partners, and so on. So you just need to know where to find them, essentially. And then we also have AWS Trusted Advisor, which, as we said, is a service that's enabled in your account that's automatically running checks to make sure that you're following AWS best practices. And also here, your support plan would dictate what level of checks or what detail of those checks that AWS Trusted Advisor does in your account, right? So let's go through a question on support. So which AWS support plan provides access to architectural and operational reviews, as well as 24/7 access to senior cloud support engineers through email, online chat, and phone, right? So again, we're looking for the AWS support plan. And by the way, I'll show you where to get those in a second. Let's just get through this question first. So it's asking which support plan gives you 24/7 access to senior cloud support engineers through email, online chat, and phone, and also access to architectural and operational reviews, right? So these are things that you sort of need to memorize for the exam, and I'll show you where you can find them. But yeah, so we have the basic plan, business plan, developer plan, or enterprise plan. All right, so this is the enterprise plan. So in fact, the enterprise plan is the only one that gives you access to architectural and operational reviews, as well as 24/7 access to senior cloud engineers through online chat and so on. So you can go search for AWS support plans, and you do need to go through this before going to the exam, right? You need to go through this before going to the test. Where's the chat window? Here it is. And you need to be aware about the differences between the basic plan. So the basic plan is explained up here. And then the developer plan, the business plan, and the enterprise plan. Just disregard the enterprise on-ramp plan. This is more of a specialized, customized plan for a different type of use case. But know the differences between the 4 of them shown there, right? So it tells you everything. Like with AWS Trusted Advisor, we have in the developer plan service quota and basic security checks. And then from the business plan, it provides you with the full set of checks, right? So obviously the enterprise plan would also provide you the full set of checks, right? And then you can see things like here, you can see that the business plan provides you 24/7 web and chat access to cloud support engineers. So that part of the question where we had 24/7 access could have been the business plan, but the thing that gave it away was the architectural and operational reviews, which I believe is only provided by the enterprise plan. Um, let's see where that is listed. It is listed somewhere. Managed services, cost management. Um, yeah, so it is listed somewhere. You can look for it, but the only one that provides you with that is the enterprise plan. So again, I would recommend going through that page and noting the differences between basic does exist. Basic is listed up here. You can see that the basic plan is included for all AWS customers and supports customer service and community. So 24/7 access to documentation, white papers, and forums. AWS Trusted Advisor, you get the core Trusted Advisor checks, right? And then AWS Personal Health Dashboard, so a personal view of the health of the services and resources that you use, right? So that's what the basic plan includes. Okay. So that's the end of the technology domain, domain 3. And so now we're heading into the final last domain, which is around billing and pricing. So in this domain, we're going to look at different pricing models for AWS, specifically for Amazon EC2. We'll look at different account structures with billing in terms of billing and pricing, and then resources available for support for billing support, that is, right? So this is about billing and pricing. And if you remember, billing and pricing takes about, let's see what that was, 16% of the exam is on billing and pricing. So you can read more about the 3 subdomains here. Right? All right, so we'll start with pricing models for AWS. And here we're going to specifically talk about Amazon EC2. So when you provision an EC2 instance in the cloud, by default, you're doing that using the on-demand pricing model, which means that you spin this when you want, and then when you don't need it anymore, you take it down and you stop paying for it, right? So on-demand, you're billed per second that instance runs for, right? Billed on the second that instance runs for, um, billed per second, and that would be for Linux or Ubuntu-based workloads, OSs, but you will be billed per hour for anything else, anything other than Linux or Ubuntu-based instances. But the main point here is that you're billed on the time that your instance runs for, right? That's what you need to know. Now, if you have an EC2 instance that you know is going to be running for, let's say, 1 or 3 years, let's say you have a database and you know that this database is going to remain online for 1 or 3 years, you can actually reserve that compute capacity in advance. And for that, you can save up to 72% off the on-demand price, right? That's with the reserved instances. This is only for a 1 or 3 year term, right? So you reserve for 1 or 3 years. You specify a specific instance configuration, like an instance type, let's say t4.large, and then how much of that capacity you need, right? And how long you need it for. And then for that, you can save up to 72% off the on-demand price. Now, there is another thing, sort of like reserved instances, but it's called savings plans. And savings plans also work on also give you up to 72% off and also work on a 1 or 3 year term. But it's more flexible in terms of committing to a monetary amount instead of an instance configuration. So for example, we can say we are committing to $8 an hour of compute usage. And for that commitment, you can save up to 72% off the on-demand price. But with the savings plans, it gives you a lot more flexibility into changing, let's say, the instance type or the OS or the region. So different properties of the instances that you launched. We have 2 types of savings plans, which give you different flexibility, right? We're not going to talk too much into each of them, but just realize that the savings plans are more flexible in terms of committing to a monetary amount, and then they provide us with a little bit more flexibility in terms of the instance configuration, right? Um, So that those are savings plans. Also work on 1 or 3 year term as well. And then we have Amazon spot instances. So the idea behind spot instances is that AWS as a cloud provider obviously has to spin up additional infrastructure to basically support those times where there's peaks in demand, right? They need additional infrastructure. But that means that during normal hours of operation, a lot of this infrastructure is left underutilized, and AWS doesn't like that. So they provide this pool of compute capacity that's unused. They provide it to us at a rate of up to 90% off the on-demand price. So by far the biggest discount we can get is with spot instances. They provide it to us for up to 90% off, but there obviously is a catch. And that catch is that these instances can be reclaimed at due to certain things that might happen. They can be stopped. And that's why we only want to run stateless workloads on spot instances, right? Only stateless workloads. What this means is that these workloads that can withstand stops and then start back up again with minimal loss, like as if nothing ever happened. Because they're stateless, they're not maintaining state on the nodes, they're externalizing state somewhere else. So if they stop, that's okay, right? Now, the reasons for why they would stop would be because the spot price that you're willing to pay, right, is lower than the actual spot price because the spot price for an instance fluctuates in terms of long-term trends in supply and demand. And you set at the start, you set a maximum price that you're willing to pay for a spot instance per hour. If the spot price goes over that, then your instance will be reclaimed. You'll actually receive a 2-minute warning beforehand, right? So those are the different pricing models for EC2. I think I went through them on that slide, but we did have an actual slide for each of them. So we'll just quickly go through this. Again, on demand is the most flexible. It is going to cost you more than the other pricing options, but there's no time commitment, right? So you can spin these up as you wish on demand, your build per second or hour that your instance runs. Reserved, again, this is when you have a steady state compute demand that you know is going to be running for 1 or 3 years. You can commit to that and save up to 72% off the on-demand price, right? Requires reserving a minimum amount of resources. So you specify how much of a certain instance configuration you want, and then how long you need it for, right? Savings plans, also 1 or 3 years, also up to 72% off, but they provide us with increased flexibility and no management overhead. So they give us more flexibility into, again, this specific instance type or the size or the region or the OS, things like that, which we don't typically have flexibility for with a reserved instance. We do with a savings plan. So for example, if we think that, oh, we reserved this much, but now we think the instance type should be different, right? The savings plan gives us that flexibility and doesn't need us to sort of forecast our needs in advance for what type of instances we need. So it reduces that overhead. And then spot instances, again, these are a pool of unused compute capacity that AWS provides us for up to 90% off the on-demand price. If your instance is stopped, you will receive a 2-minute warning beforehand, and then you can decide what to do at that point. Again, we only want to run stateless workloads on spot instances. So with that said, let's go through a question walkthrough. Which states that a company has an application that only needs to run for 2 hours at any time during a day, right? Only 2 hours at any time during a day. Which EC2 instance type will be most cost effective for this application? Oh, sorry. So again, 2 hours during the day, which EC2 instance type will be most cost effective, right? And then these are our response options. Sorry there, I forgot to switch to the slide. Um, Right. So I hope everyone had enough time to think about this. The correct answer here is spot instances. So very good for those that said spot or those that thought about it in their heads. Again, this is because we're looking for the most cost effective. Again, we said that spot instances give us 90% off, the biggest discount by far, up to 90%. It's not always going to be 90. But um, you can see in the question that we only need to run for 2 hours during a day, and this can be any time during the day, right? It doesn't matter if we stop and then come back on and run, right? It just needs to run for 2 hours during the day, right? And that's why spot instances would be the most cost-effective option in that case, right? Domain 4.2 is about account structures with AWS billing and pricing. So a couple of things to understand for this subdomain is to recognize different AWS billing and pricing account structures, specifically when we're using multiple accounts. So if we have multiple AWS accounts, um, we want to be able to track our costs using cost allocation tags, which I'll talk about. Basically, we can set tags, which are key value pairs that we can then use, right? We can tag resources based on like a project, a team, or department. And then when we're analyzing our costs, we can filter based on tags and see, for example, how much a certain project is costing us. Consolidated billing is something that we can do when we're using multiple accounts. So we'll talk about that. And we'll also talk about, right, so the idea behind consolidated billing is this is when we're using, because I'm not sure if there's a specific slide about this coming up, so I'll just explain this right now. When we are using multiple accounts, we're taking advantage of a service called AWS Organizations, right? So AWS Organizations is a service that allows us to centrally manage multiple AWS accounts and apply policies across these accounts from a central management account, right? That's done with AWS Organizations. Now, if we do have multiple accounts in our organization, we can take advantage of consolidated billing. What that means is that instead of having, multiple bills that we have to go through and pay for each of these accounts, right? We consolidate these bills into one single bill so that, there's only one management account and one single bill to pay for. And that also means that you can take advantage of volume pricing. So for some services like Amazon S3, the more you store, the less the unit price for storage becomes. So basically, it's going to consolidate your storage across all these accounts and give you the price based on how much you're storing across all the accounts, right? Things like that can make us take advantage and optimize costs, right? Okay, yeah. So different billing features like volume pricing and so on, right? So with that said, going through a question here, how can Amazon EC2 reserved instances be shared across multiple accounts? So this is something we didn't specifically talk about, but I'm hoping that you can infer the answer. So how can we share reserved instance capacity across multiple AWS accounts? Right, what does everyone think? Tanya, yeah, it's a good point, but I think they were saying that it can run at any time, 2 hours during the day. They didn't make it explicit, but in the exam, those specific things, the questions would be longer. So they would make it more explicit. They would probably say, there's no need for this instance to run all at one time, let's say, or something like that, where they're a little bit more explicit in the questions. So yeah, good point bringing that up. But when we're optimizing costs, we always want to go for, if it can be possible, we'll go for spot because it gives us the best discounts, right? Okay, so the correct answer here is, as many of you noted, B, which is AWS Organizations Consolidated Billing. If we are making use of organizations and we've consolidated our billing across our accounts, we can actually share reserved EC2 instance capacity across our accounts, right? So if we've reserved, let's say, T4.medium instances in account A, we can actually use those discounts in account B, given that we are within the same organization, right? So that is the correct answer. And then the last module is around resources available for billing support. Now, one of the primary tools for monitoring your costs in AWS is AWS Cost Explorer. So this is a service that's available to all accounts, and it allows us to easily visualize and manage our costs and usage over time. So we basically have this service which gives us a granular way of visualizing our costs on either a daily, weekly, or monthly basis. Um, and we can even filter these graphs or these reports. We can filter them based on specific services or maybe a particular region, and then we can see how much specific regions might be costing us or specific projects. And this is where cost allocation tags also come into play, as we were talking about. So we can create these cost allocation tags, which are, again, just essentially key value pairs that we can assign to resources in our account. But then we can then filter in our cost and usage reports, how much specific services are costing us, or how much specific projects or departments might be costing us, right? So that's AWS Cost Explorer. It's very feature-rich and powerful tool for monitoring your costs over time. Now, another feature of cost management in AWS is the ability to generate and export cost and usage reports, right? So the main difference between cost and usage that a cost and usage report will give us is that cost and usage reports give us the most comprehensive and detailed data, right? They allow us to export a CSV file, and we can send these reports to different locations, a common one being Amazon S3. And then from there, we can use BI tools like Amazon QuickSight to visualize our costs in our own way if we want to, right? Um, so cost and usage reports versus Cost Explorer, the main difference is that Cost Explorer, which we spoke about, displays high-level visualizations of current and historical account costs, whereas cost and usage reports generate granular usage reports in CSV formats. So this is the most detailed reports that we're going to get. Again, we can send these reports to a storage and then use that to run SQL queries or visualize our costs in our own ways, right? So main differences between these. And then we also have, again, we spoke about Amazon QuickSight a bit. That's our visualization tool. So if you use things like Tableau, it's sort of the same, but this is Amazon's native tool. And this would be a potential destination for our cost and usage reports so that we can create our own visualizations. Now, the exam is not going to ask you specifically about how QuickSight works or anything like that. Just know on a high level what it's used for, right? In addition to QuickSight, we also have tools on the AWS Marketplace, a range of different BI tools that you can find there. So just know that that's a resource as well. And then lastly, you can always head over to a specific service's pricing page. So for example, if you're looking for details about prices, if you search, for example, S3 pricing, that should give you the pricing page. And you'll know that because it's always aws.amazon.com/service name/pricing, right? And that will give you details about the services pricing. So those are resources available to us. Now let's go through a question around this subdomain, which asks us, which AWS service or feature allows a company to visualize, understand, and manage AWS costs and usage over time, right? So again, watch out for these keywords: visualize, manage, and understand costs and usage over time, right? So here are the responses. Anais, sorry, there's no way for me to send all these links out to you. I don't have access to your emails, so if you could just take them down from the chat, right? Because there was about 2,000 people registered for this session, so there's no way for me to send those out. Sorry about that. All right, so a lot of you are going for B, and that is the correct answer. AWS Cost Explorer. Whenever you see the word cost and usage, right, we're looking at Cost Explorer, right, in the exam. Whenever you see that word cost and usage, unless they're asking for detailed cost and usage reports, which we can export in CSV, then if there's an option cost and usage reports, it would be that option. But again, Cost Explorer gives us a high-level visualization of our cost and usage. Current cost and usage and historical cost and usage over time, right? And that's the end of our session. We're a little bit early here, 5 minutes early. That is the end of our session. Again, thank you everyone so much for attending today. I did want to drop in a couple of things here. So one of our trainers, Dan Puser, actually created a page with different notes for the Certified Cloud Practitioner test. So I'll drop this in the chat. These are Dan Puser's notes. And they're pretty good. He goes through different exercises that you can test yourself out on. So you can see exercises for each domains and self-paced labs and different resources to read through specifically for the cloud practitioner test. So there you go. It's in the chat. Other than that, at the end of the exam guide, so we've reached the end of the exam guide, you'll see the appendix, right? So make sure you also go through the appendix because these are also potential services that can be asked about in the test, right? So you can see here, we didn't go through services like, for example, Amazon Code Commit, but on a high level, you should know what Code Commit is. It's our managed Git control or source control service, things like that, right? So on a high level, these are potential services that could be asked about. So you should have a sort of an understanding about what each and every one of them do, right? And that's it. That's all I wanted to add. There's also the sample questions, which you can go through if you feel like going through them right now. You can go through them right now. So there's 10 questions here, which you can use to test your knowledge on. And the answers to the questions are below as well. So I'll also put the sample questions in the chat. And then that is it for our session. Again, thank you all so much for attending. Thank you, chat support team, for answering those questions. But yeah, we will be ending the session soon. I'll leave it open for a few more minutes in case anyone has any overlaying questions. But again, thank you so much and enjoy the rest of your week. Thank you so much, everyone. Appreciate it.